So here we are going to derive the shape function for a bar element. Already we have derived the bar element equations in one-dimensional element derivation. Here we are going to assume the polynomial function of quadratic equation. So let us take a quadratic element which has three nodes. In previous derivation we are only considering the two nodes at ends. Here we are going to add another node in between the element at x equal to L by 2. So the displacement is considered in this direction. So including the shape function, the displacement equation is n1u1 plus n2u2 plus n3u3. So it's our wish to use the number of shape functions in the assumed equation. Already we have derived the displacement function for the bar element using only two nodes. Here we are going to consider three nodes in a bar element. So our assumed equation is a quadratic equation in which the C0, C1 and C2 constants are considered. So the assumed equation is C0, C1 and C2. Here we are going to find the value of C0, C1, C2 so that the displacement equation will be in the complete format. From this we can find the stiffness matrix. So the outline of this derivation, finally we are going to derive the stiffness equation. So it is with the help of B transverse B E A dx, where B is the transformation matrix, which is the combination of all shape functions. So dn1 by dx, dn2 by dx and dn3 by dx. So this is the B matrix. So if you transpose this matrix, the three element of this matrix, and multiply it with this B matrix and multiply it with the material property EA, we get the stiffness equation. So we are in the need to find out the shape functions. So the shape function means it is an interpolation function between the global displacement and to the local displacement. If you keep u of x is the global displacement, u1 is the local displacement at node 1 and u2 is the nodal displacement at node 2 and u3 is the nodal displacement at node 3. So if you find the constant value and if you assemble in terms of u1, u2, u3, you will get some function. That function can be equal to the shape function. So first our aim is to find out the constant values. For this we are going to use the boundary condition. At u of 0, the displacement is referred as u1. That is the displacement at node 1. At u of L, the third node, the displacement is u2. At u of L by 2, midpoint, the displacement is u3. So this is our initial boundary conditions we are assumed. So with this boundary condition, we try to find out the value of C0, C1 and C2, and we are going to assemble this equation in terms of U1, U2, U3 so that we can get the value of shape function. So first I am going to apply the first boundary condition U of 0. So U of 0 equal to, if you put x equal to 0 here, only C0 will remain. That can be equivalent to U1. So we can find the value of C0 as U1. Next you substitute U of L in this equation. C0 plus C1L plus C2L square. We already know C0 is U1. So I am putting U1 plus C1L plus C2L square. So what is of u of L? The u of L is u2. So we can equate to u2. So I am going to simplify this equation as C1L plus C2L square, which is equal to u2 minus u1. So I am keeping this equation number, here it is 1, here it is 2. Next I am going to apply u of L by 2 in this equation. So C0 plus C1L by 2 plus C2L square by 4, which is equal to C0 is u1. So u1 plus C1L by 2 plus C2L square by 4. U of L by 2 is u3. Already we have defined the displacement at midpoint as u3. So you can equate to u3. So I am going to simplify this equation as C1L by 2 plus C2L square by 4, which is equal to u3 minus u1. So take, this is equation number 3. We are going to solve equation number 2 and 3. Solve equation number 2 and 3. So I am going to multiply the third equation with 2 because denominator there is a value 2. So to cancel the value, I am going to multiply 2 with this equation 3. So the third equation will become C1L plus C2L square by 2, which is equal to 2u3 minus 2u1. Whereas the second equation I am keeping the same, C2L square, which is equal to u2 minus u1. So now we can cancel the C1 term to get the value of C2. So C2 is equal to L square by 2 minus L square. So here I am going to combine all the terms, 2u3 minus 2u1 minus u2 plus u1. So if you take LCM, it is minus C2 into minus L square by 2. Minus L square by 2 is equal to, simplify, minus 2 1 and plus u1, minus 2u1 plus 2u1, it is minus u1 minus u2 plus 2u3. So if you take minus L square by 2 outside, on the other side, C2 equal to 2 by L square, multiply with the minus value u1 plus u2 minus 2u3. So we got the value of C2. We got the value of C2. By using the value of C2, we should find out the value of C1. So I am going to substitute in equation number 2. Substitute C2 value in equation 2. So C1L is equal to u2 minus u1 minus C2L square. So u2 minus u1 minus C2 is 2 by L square, u1 plus u2 minus 2u3 into L square. So we can cancel the L square value and you multiply minus 2 inside. So u2 minus u1 minus 2u1 minus 2u2. Here it is minus, so it is plus 4u3. Plus 4u3. So C1L, so we can simplify this minus 3u1 because minus u1 and minus 2u1 is there. So minus 3u1 minus 2u2 plus u2 is there. So minus u2 plus 4u3. So the value of C1 is 1 by L minus 3u1 minus u2 plus 4u3. So we got the value of C1, C2 and C0. Previously C0 we are having. So now we are going to complete the displacement equation, the quadratic equation. C0 is u1 plus C1x. C1 is minus 3u1 minus u2 plus 4u3 by L into x plus c2 x square. C2 value is 2u1 plus 2u2 minus 4u3 by L square into x square. So we completed the displacement function. I am going to separate all the term because I need the u of equation in the form of some shape function into u1, some shape function into u2, some shape function into u3. So I am going to separate all the terms in this equation. So u of x equal to u1 minus 3u1 x by L minus u2 x by L plus 4u3 x by L plus 2u1 x square by L square plus 2u2 x square by L square minus 4u3 by L square into x square. So now it is easy to assemble this equation in terms of u1. So u1 you take, if you take this u1 outside, so 1 minus 3x by L. So we have completed these two terms. Another term here in terms of x square plus 2x square by L square. The next in terms of u2, if you take u2 common outside, here it is minus x by L. So we consider this and plus 2x square by L square. So we consider this also plus u3. So the remaining terms is 4x by L minus 4x square by L square. So now we get the shape function values. So n1 is equal to 1 minus 3x by L plus 2x square by L square. n2 is minus x by L plus 2x square by L square. n3 is 4x by L minus 4x square by L square. So we have completed finding the shape function. So in our examination, either the question may ask to find out the shape function or to find out the stiffness matrix. Anyhow, you have to understand the procedure to find out the shape function first. Since the derivation is very long, so I am going to derive the stiffness matrix, that is element matrices, in the next video.